S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we all know that what is the role of oscillation? We are using the communication circuits in all the industries. So welcome to the SN Academy. My name is Kanhaiya Jha. In this video we will learn what is the oscillation is, what is the positive feedback, how the output is coming more than the input. We will make all these kind of circuit and we will learn in this video.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
First we come to the particular term called oscillation. So basically the idea that comes in the mind that what is an oscillator, and in what we say in oscillator that we get the output which is more than the input. So question comes here that every kind of machine that we are using, they have loss factor, that when we are using them they have a loss factor. So how it comes that we are getting the output not even which is equal to the input, but it is many times greater than the input. For example, as you see here that if we say that this is the input and it goes to the amplification, so in the amplification it will be the output. So we can see that the output is more than the input, but what we have learned till yet is that every machine, when we proceed with machine and we proceed from the input to the output, from the output we will get a loss factor also. So how it is possible to design a machine that the output is not even equal to the input, but it is more than in terms of the output. So we learn in this oscillator that how we are getting these kind of outputs, what kind of calculations that we are doing, how we are using the different components like transistors and all, or how we are making the transistor input or output variation, that we are getting the output which is not even equal to the particular input, but it is many times higher than the input. So we learn here in this particular chapter. So the objective here is that the basic concept on oscillator, the principle and the operation of the oscillator, and then a very important concept that which kind of circuit that we are using in the oscillator. So we are using the resistive capacitive, that is RC, and then the inductive capacitive LC circuit in the particular oscillator, and what are the basic calculations that we can do with the oscillator. So first of all, coming to the basic, let us understand that what exactly the oscillator is. I am making a simple circuit of a transistor. So this is basically a simple transistor, okay, where we are not looking for any configuration here. So we can say that there are two parts here. One is the input and one is the output. Now one is the input part and one is the output part. Now first of all we will learn that what is oscillation is. So when we give the input to this particular input, it will come here and then it will go to the particular output, what we have learned. So when we give the input and when it will come here, then we will say that whatever the input that we have given, only 0.01% will go to the output. So when we say that only 0.01% will go to the particular output, so if we make the input wave like this, then what is required, what we generally say is that only this will be utilized and the rest will go to the output. So we can see that how the input is less than output is more. So basically when we are saying about the oscillator circuit, yes, they are bilateral circuits. Bilateral circuits in the sense that we can move from the input to the output, and from the output whatever the loss factors are, they can be recycled to the particular input. whatever the loss factor that we have, they can be recycled to the particular input. So when we say that the uses in the output is 0.01%, then the rest is given to the output. So when we make the variation in terms of the input and the output, then the input is very less and the output is very high. So this is basically the working principle of every kind of oscillator that we generally use. Then we have oscillator. Basically there are electronic circuits that generate periodic waveforms in terms of the output with the input wave signal, and from that where we get the output wave signal. There are very varieties of the uses, increases rapidly as we are saying. Oscillators, let's take an example. When we are watching TV, then what we do? The two operations are very simple, that either you increase or decrease the volume and you change the channel. There are two things which are very common when we are watching the TV. So when you are changing the channel, then what happens here, that you are setting your TV circuit at different frequencies. As we can say that we have a frequency variation. We start from the VLF, LF, then we have HF, then VHF, then UHF, and then the V above that. So we start with a very low frequency, then we go to the low frequency, then high frequency, very high frequency, ultra high frequency. So what we are doing is that when we are rotating the remote with the different channels, then we are setting our TV with a different values of the particular frequency. So we can see that the channels which are available on the low frequency, they are not that particular costly, but the channels which are available at a very high frequency and further, they are costly. So what we are doing is we are doing we are setting that one particular circuit at a different frequency. So what happens, that the TV set is basically giving a particular carrier wave, and a carrier wave will overlap with the target wave which is given by the transmitter, and then we are saying that we can get the particular message or the particular signal, or we can see that particular channel. What we can see here, that produces a repetitive signal from the DC voltage. So in a block diagram, when we want to study this, that the positive oscillator replies on a positive feedback of the output of the maintained oscillation. The relaxation oscillator makes the use of the RC timing circuit to generate a known sinusoidal signal such as a square wave. So basically you might have done the two kind of waves. The first is sine wave. The sine wave, we generally say that it is an analog wave. In the analog wave, that we can do the calculation at a two particular point. One is the start point and one is the end point that we can do. So whenever there is a distortion in the signal, we cannot calculate that particular distortion, because the distortion cannot be calculated, because the calculation can be done at a two particular points. One is a initial point and one is a final point. So when this particular sine wave goes through an oscillator, then it is developed into the digital, which is a square wave. So as we can see that here, it is the first initial point and the last point. Here we can see that the pulse are the small time intervals, okay, and then it will show that the pulse rise is this is the pulse duration, and this is the pulse fall. So it will show us that what is the pulse rise, what is the pulse duration, and what is the pulse fall in this. So as this particular oscillator, as you can see the RC circuit, that RC circuit is the resistive capacitive circuit, and we are using the inductive circuit, one in the input and one in the output. So the purpose of using the inductive circuit, one in the input and the one in the output, is that if there is some loss in the input of the signal, because if the inductor has a loss in the input, then from the output it will flow to the input, the inductor number 2. So we say that it is always a positive feedback. Then we have the types of oscillator. We have Wien-Bridge oscillator, we have a phase shift oscillator, then we have this kind of Hartley oscillation, crystal oscillation and all that. So, what kind of what we generally say unijunction relaxation oscillator. So, these are the particular types that we will study in the oscillator. So, first of all, feedback oscillator. First of all, feedback, we should understand the concept, the feedback. The feedback is basically that when any particular oscillator is sending a carrier wave and that particular carrier wave will overlap with the target wave, then the oscillation is done. And if the overlapping of the carrier wave and the target wave is not done, in that case we cannot say that it has a positive feedback. So, we can see that in the positive feedback of oscillator circuit, okay, when switch at an amplifier input is open, no oscillation will occur when the switch is open. We have to close the switch, then the voltage will travel. Then Vi is an input voltage, Vo is output voltage. So, V output is equal to A into Vi and the V feedback is equal to beta into AVI, where beta, as we have done in the lower classes, beta is the current gain, or we can say that beta is the amplification gain. So, beta is the amplification gain. So, for the positive feedback, Vf is equal to beta into the A into Vi, Vi is the input voltage. So, the feedback voltage is beta into AVI, where beta is called as the loop gain also or the current gain also. So, in case of maintaining the positive feedback, that is equal to Vi, beta A must be in the magnitude and it has to be in the same phase. So, what we have to say that in the oscillator, if you want the positive feedback, in that particular case the current should flow from the input to the output and we will calculate the current gain, and when you will calculate the current gain, we find that the current gain beta factor is to be high. So, oscillation can happen in the same phase, because when we are doing the one wave in the one phase and the one wave is out of phase, suppose the input and the output they are out of phase, in that particular case overlapping will not happen, then the signal will intersect with each other. So, we will not get the oscillation value. So, we can see that they have to be in the current magnitude and they have to be in the same phase. So, when they are in the same phase, it means that the oscillation can generally happen. Then we have the basic principle. The basic principle is the V, Vs plus Vf, and Vf is equal to beta naught and beta naught is equal to AVE. So, this is the basic principle where we can calculate the output voltage also, and then we can calculate the closed loop gain also. From the particular current gain, we can calculate the closed loop also. So, here what we conclude here, that what exactly the oscillator is, how we are calculating the input signal and the output signal, how the variation in the input signal and output signal is calculated, and we are doing the different calculations in this. So, now we will take a small break, and again after the break we will discuss the different kinds of oscillators and how to make the calculations in this. Thank you.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Hello students, welcome back. Till yet what we have learned is that what is the oscillator, how we are getting the positive feedback of oscillator, and then we have discussed that how the LC circuits are important, how we are using the one inductor in the input and how we are using the one inductor in the output, and if there is a loss in the input, then how the induction is carried out from the output to the input and how to make the calculations. And now we will proceed further and we will make the calculation. So, we have done this in the open loop. Then we have a basic principle. There is a transfer function which is As into Bs, where Bs is again a gain. So, we will calculate the gain factor as this. So, this is the criteria that is called as a Parkinson criteria, where we say the condition of the sinusoidal oscillation frequency f naught A j omega naught into beta j omega naught is equal to 1. So these are, we can see that in the previous slides we can see that what is a T j omega naught and AF j omega naught, and then when we relate this particular value, so this value has to be equal to each other and has to be equal to 1. So the frequency of the oscillation is solely determined by the phase characteristics of the feedback loop. The loop oscillates at a frequency for which the phase shift is 0. So we can say that phase change is 0, again repeating that for the proper oscillation and for the proper feedback and to get the higher efficiency, both the input and the output has to be in the same phase. So here we can also see that the phase change is equal to 0. Phase change is equal to 0 in the sense that input and the output has to be in the same phase in terms of oscillation. Then we'll have discussed the basic feedback of oscillations and all that. So students, now will learn Venn bridge oscillator, that what exactly the Venn bridge oscillator is and how we are going to use this. So as the name says, bridge. So we'll make a bridge, like we can see that there are 4 resistors, R1, R2, R3 and R4. Like we have, you can see this structure. This structure is moreover same as a Wheatstone bridge. And after this particular Wheatstone bridge, you can see that this is the part which is grounded. And then again we are using this with a voltage source Vs and minus Vs, plus Vs and minus Vs, using op amp, and then we are getting the output. So what we are doing is, one part you can see that here it is connected to the positive, and the one part here it is connected to the negative. And then here we can see that how the input is connected to the particular output. So as what we have discussed in the basic operation of the oscillation, that the input will flow to the output and whatever the loss factor will be recycled to the input. So we say that if we are giving the 100 to the output, only 0.01% will be used. Rest of the things are goes to the output and again recycled. So again we can see that how this particular bridge is connected to the particular operation amplifier, and again and after that we are getting the particular output. So how the input and the output are connected to each other, and after the input and output are connected to each other, then how the flow we are calculating from the output to the input. So we can see here that in the Venn bridge oscillator, the working of the oscillator, the feedback signal of the in this oscillator circuit is connected to the non-inverting input, as we have seen in the circuit terminal, so that op amp works as a non-inverting amplifier. So as we have seen in the particular previous circuit, that how it is connected to the inverting and non-inverting mode and how we are getting the particular output. So the condition of the zero phase shift around the circuit is achieved by balancing the bridge. Zero phase shift is essential for sustained oscillation. So again we connect the bridge to the operational amplifier with the inverting and a non-inverting mode, and again we are focusing that the input and the output must be in the same phase, because if they are out of phase then we cannot do the oscillation. The frequency of the oscillation can be calculated as f naught, which is equal to 1 by 2 pi RC. RC is a resistive and the capacitive circuit, whatever the value that we are getting. F naught is a resonant frequency, and the inverting and the non-inverting voltages will be equal and in phase, and the negative feedback signal will be cancelled by the positive feedback, causing the circuit to oscillate. So when the input and the output are in the same phase, then we will get only the positive feedback circuit, and the negative feedback circuit will be cancel out each other. So the circuit factor has a current gain factor beta 1 by 3 of the oscillation, and we can calculate amplifier from that, and we can calculate the ratio as RF by RI. The loop gain of the oscillator that we can calculate as a transfer function AS into beta S 1 plus R2 by R1 over the impedance P is P JP plus JS. So JP is equal to R 1 plus SRC, and then you can calculate this particular function also. So we have here this particular value, and when we substitute the value of the Tj omega, then we will get the value of the Tj omega. So again 1 plus R2 by R1, so 1 by 3 we can see that j omega naught RC plus 1 by j omega naught RC. This is what we have to calculate. So we have a frequency of the oscillation which is Tj omega, and for the zero phase condition the imaginary component is this j omega naught RC plus 1 by j omega naught RC is equal to 0, and then we'll get omega naught is equal to 1 by RC. So this is the particular value that we are getting. So the particular magnitude condition, the magnitude condition is 1 is equal to 1 plus R2 by R1, 1 by 3. So R2 by R1 is equal to 2. This is the magnitude condition where we will calculate the ratio of R2 by R1. We will always calculate the ratio. R2 basically we can use in the output, and the R1 we can use in the input. So the ratio of the R1 to the output will give us a calculation, the condition calculation, that how the oscillation factor is generally done in the particular circuit. So we are calculating this, and in the we are getting the R2 by R1. So R2 by R1 giving a positive thing, positive value will indicate that we are getting a positive feedback. So the positive feedback can only be ensured when both the input and the output are in the same phase. They are not out of phase, and when they are not in out of phase, then we will always get the positive output. Then we have a ratio R2 by R1 is equal to 2. So K is equal to 1 over R2 by R1, which is equal to 3. So K is equal to 3 ensures the loop gain is unity, and K is greater than 3 growing oscillation, and K is less than 3 is a decreasing oscillation. So when we can see that the value of the K is greater than 3, or it is in the increasing number, we are saying that it is in the growing oscillation, and where it is less than 3, it is in the decreasing oscillation. So what we have learned here, that what is the oscillation, how we are calculating the different parameters with the particular oscillation, how the calculations can be done, why the input and the output has to be in the same phase when we are calculating in the oscillation, how the gain factor can be calculated. We have discussed the different conditions where we can calculate the oscillation, how the input will flow to the particular output, and then again it will recycle to the particular input, and we are calculating the oscillation factor. In the Venn bridge oscillator, we have discussed that how we are making a bridge, we are connecting with a operational amplifier inverting and a non-inverting mode, and then making the input and the output in the same particular phase, then we are calculating the oscillation particular factor. So hope this video will enable to enrich the knowledge about the oscillator, and hope you have enjoyed the video. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.